Hello and welcome to this session of 5 for 5th, where today we're going to be discussing teaching fractions of fractions, which is grade 5 of our everyday math program. And we're really going to focus on the why behind multiplying fractions. By that I mean, why are we doing what we're doing? Why are we just multiplying numerators and denominators together? And if your experience was anything like mine growing up, the teacher told me to do it that way. I did it that way, but I never really understood why. And even more importantly, if I forgot the rule, I had absolutely no conceptual understanding to help me figure out what to do in that case. So what we're going to do today, again, is focus on the why behind multiplying fractions with fractions. Okay, let's begin by taking a look at 2/3 of 1/2. And we want to really take a second to talk about this in depth. When we're reading the problem, it says 2/3 of. So you have to step back and you have to say to yourself, 2/3 of what? Well, 2/3 of 1/2. That can be confusing because the problem starts with 2/3, yet we're really looking at the 1/2 first, because that's what we're taking 2/3 of. Now, I've probably just totally confused you at this point, so let's rephrase it. The problem says 2/3 of something. When we look at what that something is, we begin to understand the problem. In a minute, we'll investigate this further with a unit box, but I just want to take the numbers out of this and talk about just real-world scenario. Suppose I had a recipe for 8 people. I was going to have a small dinner party for 4. I obviously need to cut the recipe in half. Thinking about this, I'm making only half of the recipe. So again, I'm only doing half of the recipe. Now, if I'm going to be making my recipe, I have to start by looking at the recipe first and cutting all of the components in half. So that's kind of where we're getting at. 2/3 of what? 2/3 of 1/2. Well, let me analyze 1/2 first and then take 2/3 of that. It's a lot of verbiage, everybody, but just bear with me and we'll break this down really smoothly. So now when a real life scenario is not provided, we're left with these very basic, very blah looking problems. So let's take a look at it again visually. We're not just going to multiply. We know 2 times 1 is 2. We know 3 times 2 is 6. We know the answer to this problem is 2/6. But the question here is, why is the answer 2/6? So let's begin. I'm taking 2/3 of something. I'm taking 2/3 of 1/2. First thing I'm going to do with a unit box is visually look at 1/2. There's 1/2. Now I need to take 2/3 of that. So I have to divide this unit box now into thirds, and I'm taking 2 of those thirds. So now I'm going this way. What do we have in common? The 1/2 was here. 2/3 of that means I have this section and this section where they're overlapping. That means I have 2 out of a possible 6 boxes. Okay, now we're going to do quite a few of these, so we'll try to, again, keep it slow so we catch on. We start with the first fraction, and we make our intervals within the unit box, and then we'll go horizontally. So the next one, 1/2 of 3/4. Well, I need to take a look at what 3/4 visually looks like. 1/4, 2/4, 3/4, 4/4. Here's 3/4. If you had 2 different colors, that would really be nice also for the children. Now I want to take 1/2 of that. Now I'm going to split this in half. And I only want to take half of these 3/4. What am I left with? I'm left with 1 overlapping piece, 2 overlapping pieces, 3 overlapping pieces. 3 out of a possible, how many sections? 8. And again, we knew through our multiplication algorithm, the answer is going to be 3/8, but here's why. Okay, another one. 1/3 of 4/5. Here we go again. And hopefully you're all saying this to yourselves. First thing I'm going to do is break this into 5 intervals, of which I want to shade 4 of those 5. I have 4 of the 5. And then I want 1/3 of that. So I need to take my unit, cut it into thirds, and I only want 1/3 of that. This is irrelevant because this didn't belong to the 4/5 anyway, so I have 1, 2, 3, 4 overlapping pieces out of a total of 15. Okay, again, I know that this is much longer than simply multiplying across, but we're really trying to teach the students for conceptual understanding. We need to show them the why. Next one. Uh-oh. 1/6 of 3/8. I should have made this much larger. All right, I need to have 8 intervals. 1, 2, 3, 4, 5, 6, 7, 8. I want 3 of them. Now I have a unit box that's showing 3/8. Within this unit box, I want 1/6. 1, 2, 3, 4, 5, 6. And please don't be alarmed. The children might do the first one and know that they're only going to have 3 intersecting pieces. So here's my 1, 2, 3, but we want to instill that, making it 6, so they can see the total number of rectangles that this provides. So I have 48 total pieces, of which 3 are overlapping. Okay? Now that's it. That's seeing the problem visually, not just simply multiplying numerators and denominators like most of us were taught, and taking a good look at the why behind the arithmetic. If you need a hand, please give us a call. Thank you so much, and we will see you at the next 5 for 5th.